Okay, we are now in the engine bay of a Toyota Prius C. Now this is a hybrid vehicle. So what we have is the internal combustion engine, or the ICE for short. And it also has an inverter, and it has a electric motor. So basically for hybrids, it runs both the engine and the electric motor. Okay? Now, similar to all ICE vehicles, for the engine, you will have the air intake system and the exhaust system and the fuel rail and all other parts that are associated with an ICE engine. As for the high voltage system, we have the inverter here. Now, if you can see, there's an orange color warning label and also the orange colored cable. These are typically some of the identifications that you can use to identify whether the vehicle is a high voltage vehicle. Now, the inverter basically performs a function of converting the current from the battery into alternative current, AC current, to supply into the electric motor. All batteries comes with DC current, direct current. So if you can see this cable, it runs to the floorboard of the vehicle, and it will move into the high voltage battery, which is located at the rear passenger seat. These two other orange color cable, it goes into the electric motor and the electronic compressor. Now, once current comes from the high voltage battery into the inverter, what the inverter does is that it will snaps up the direct current into perhaps 300, or some cases even 400 direct current volts, and converts it into alternating current to supply into the electric motor. All high voltage vehicles, which includes hybrids and pure EVs, their electric motors runs on AC current, which is much cleaner using electromagnetic field. Now, before you, or rather if you look here, there is a coolant. Now this coolant is specifically for the inverter. We all know that electricity carries heat. So the higher the current, the more heat there will be. So that's why it requires a coolant or a cooling system itself for the inverter. For the EVs, what you can see is that because they do not have the internal combustion engine, what you will find is probably an inverter and another unit, which what we typically call as a DC-DC converter. And you would have larger size motor because the space of the engine bay is much wider since there is no internal combustion engine. So the DC converter, basically what it does is that it takes the high voltage power from the battery and steps down into a 12 volt DC current and then charges into the 12 volt auxiliary battery. All high voltage vehicles, EVs and hybrids, they will have a 12 volt battery, right? So this 12 volt battery basically supplies the current to the accessories, for example, like your radio, your folding mirror, and your alarm, because these are considered low voltage and requires the 12 voltage batteries to supply the power. Now, what we're going to do is that before we work or on this vehicle, we need to isolate the high voltage system. Isolating the high voltage system, basically what it means is that you are cutting off the supply into the inverter. So what we will do is that we remove the service plug and isolate the high voltage system for this vehicle, and we will need to wait for 15 to 20 minutes before we actually start removing any components on this vehicle. The reason that you need to wait for 15 to 20 minutes is because in this inverter, there will be residual current, and you need to let the residual current drain off before you actually start working on a high voltage vehicle.